Hey, I'm here at Taylor. I'm dropping off this rotating wheel display, so let's have a look. Okay, I'm going to show you how it works. I've got it set to go at a faster speed than it's actually going to go at. All this is going to be in a display case, and these pedals here are going to be also exposed to the audience. So when people come up, they can press these pedals and make the wheel rotate. It's going to go slower, but it's fun just to see what it can do. Okay, so it's the accelerator pedal, and that's the brake. Yeah, that's kind of fun. All right, let's go around the back and have a look how this is built. Okay, here we go. All right, so here's the tire, the wheel, and it's connected to this, what's called a wheel adapter. It goes from one lug nut pattern to another, but I'm just using it to connect this axle. So we've got this shaft collar, which attaches from here, from the wheel adapter to the shaft of this axle. The axle itself is reinforced or kept in line by these two ball bearings. Big, large ball bearings purchased from McMaster-Carr, as was this sprocket here. So the sprocket's on this roller chain, and the roller chain is turned by this DC motor, which is meant for scooters. So that's just mounted to this plank. The ball bearings are mounted to these 2x4s. Everything's held in place by this frame that was also purchased from McMaster-Carr. Most of the stuff was. Oh yeah, nice little detail are these to prevent the shaft from slipping that way or this way. We've got these other collars here and here, which just clamp it down so that it can't slip. Yep, so that's the construction of this. Anyways, the motor feeds into this Arduino over here that's running a hefty motor controller, and then into this screw terminal board there are the pedal outputs. The outputs from the pedals feed into the analog pins here, and the pedals just feed out signals from these pots, potentiometers. Yeah, so it's pretty straightforward. As you press, let's see if I can do this, as you press the pedal, the pot turns a little bit, and I use that as a control signal to control the speed of the tire, the wheel. And then the brake, it's not doing anything so impressive right now. It's just reversing the direction. So what I've got to do is actually account for the position and the rotation of the wheel by attaching an encoder, perhaps. Maybe that's overkill, but the problem is right now, what you can see is that I'm spinning in this direction, and this is what the brake really does. It just goes in the other direction. So I've got to actually account for that so that it can never go in the opposite direction fully. Yeah, okay, anyway, so that's it. I've been working on this for like weeks now, and it's been a lot of design in CAD, Fusion 360, which is great because it integrates with McMaster-Carr. So I was able to import a lot of these parts to make it work, to design the contraption. And fortunately, when I finally decided on the design, I just ordered everything and was able to put it together relatively seamlessly. So that's a really nice procedure, to limit the amount of like fabrication you have to do and the mistakes you make there by doing everything in CAD. Of course, that's what it's for. Okay, so if you have any questions, let me know. And I'll upload some images and some video of the final display once it's available. Thanks.